Hi everyone, good evening. I hope all of you can hear me loud and clear. Yes. Guys, just respond in the chat with a yes or no. Can you guys hear me? Yes, perfect. Thanks, Shreya. Good evening, guys. Okay, so I see a lot of members have joined the session today. It's going to be a pretty exciting one. I hope everyone enjoys it just as much as I am going to while explaining these things to you. Okay, so let's get straight to the point, right? Today, we are going to talk about the evolution of generative AI, right? So the idea is that today we hear a lot about generative AI, ChatGPT, Claude, Anthropic, Llama, Mixtral, so many of these different technologies that have come up, and they've come up in a very, very short span of time. So in the last 1 year or 2 years, there has been a huge progress in the awareness and acknowledgement of generative AI as a technology, as well as the predictions that there's going to be an completely autonomous general AI coming up soon, which could act as, the robot of the future, which can do anything, right? So to first give you guys a quick, very short summary, we are far, far away from a generic AI, universe, right? That's way too in the far. So if you want to know why and how these technologies are built and why the human race is going to take a long time before we reach a completely autonomous AI, this is the webinar for you. Okay. So first of all, let me quickly take a poll across the board. How many of you have heard about the term generative AI, right? How many of you have already heard about it? And how many of you are hearing it for the first time? First timers, FT, all of you who've heard about generative AI as a technology first time. Priyanka has heard about it first time. Okay. Shreya first time. Sandeep first time. Okay, lots of folks for first time. That's great, guys. Today you're going to be introduced to a whole new world of technology. So it's going to be awesome. Okay. Have you guys used ChatGPT? Have you guys heard of ChatGPT, used it, tried things out with it? Doesn't it seem like magic? When you first use the tool, don't you think it was like a magic kind of a thing? It completely understood what you asked. It solved the problem directly, and it solved in a very nice way, right? It did not just answer the question. It gave you an explanation. It gave you a process of thinking. It gave you the understanding, the answer, the way it came to the answer, all of those, right? So the idea here is ChatGPT and a lot of such other tools are basically coming out of the larger envelope of technology, which is generative AI. Now, why do you call the term generative? Okay. So first of all, it's very important for you to understand these two terms very, very clearly. Okay. The first term is generative. That means it generates something. Okay. Right? There are different branches of AI. There is predictive AI, where you predict something, right? There is prescriptive AI, where you prescribe something using AI. But in generative AI, you are generating. That means you are inventing something new, right? To the common public, it always feels like something new is coming up. Well, that's truly not the case, and we'll see why. And the next term is AI, which is artificial intelligence, where you somehow want to create a system, a technology, where intelligence can be achieved via a machine, a non-living entity. So you want to generate something new using intelligence, which is artificial. Is that clear? All of you? Guys, yes, no?
Yes, sir.
Okay, perfect. Now we'll break down these terms one by one, but we'd first like to know the history of origin. Where did this start from and where are we today? Because only when we understand the past and the transposition from the past to the present, we'll be able to figure out where are we going from the present and into the future. Okay, let's look at that one by one. So generative AI is artificial intelligence that creates new content, right? It could be a text content like you've seen ChatGPT, it predicts something, some new word after something. It could be images, it could be music. But the very primary confusion that I want to completely remove from your mind at the beginning of this webinar is that it's going to generate something new which the world has never seen. That's absolutely, absolutely wrong. Okay. When you say it generates new content, that means it picks up the existing universe and tries to create a new universe, more like a parallel universe from the existing universes. Okay? It does not create a new universe completely. This is not disconnected from the existing universe. It is connected. For example, I ask you to read about a topic. Okay, I give you an example. Let's say I tell you, go read about deep learning. What would be your usual process? Your usual process should actually be like, go to Google, search for deep learning, go to Wikipedia, learn about it, watch some YouTube videos, read some online articles, talk to some friends, do a few projects. After doing all of these, you will be able to say that you are confident about deep learning. You would say, okay, I now understand what deep learning is. Then I ask you to write a brand new article on deep learning. Okay. I ask you to write an article, a research paper, any content about deep learning. Are you generating this from your own mind? Yes. But what was the data that was fed to your mind? It was all of these original resources. Okay. So generative AI today does not have the power to invent something completely new, which the world has never seen before. It is able to mix and match, stitch items from multiple places and assemble them together into something that looks new. But bits and pieces of this are already available in the data this model, this algorithm was trained on. Does that make sense, all of you? Yes, no?
Yes, sir.
Yes.
All of you? Great. If you don't want to turn on your microphone,
Yes,
just
sir.
say yes on the chat would be very helpful. Okay. So it does not actually create new content. That content existed. It just found a way to mix and match, merge ideas together. And these ideas could actually be generating text like ChatGPT or other tools, which are textual models. So you must have heard of the term large language models. So ChatGPT uses GPT-3, which was a large language model. So language means it is generating text. Then there are other models like the vision transformer. What does it generate? It generates images using algorithms like stable diffusion and a lot of other computer vision techniques. It also can generate music, right? A lot of different things can happen, right? But the idea is they are generating some kind of information which is fueled by information that was already existing, but it was split across multiple sources. There was multiple sources of data. We trained a model which can now generate new information. Okay, new, not brand new, new, but it can new means it is generating information from what it learned. Okay. Now, moving on. What is the importance of generative AI? Now, because you guys have joined this webinar, I'm pretty sure you understand the hype, you understand the value, and you understand the importance of why you should learn something like this. Okay. So there's a very famous quote which says, if you want to beat the market, keep track of the market, right? Where is the market going? Initially, if you remember 5 years back when I was completing my engineering, there was a lot of talk about the role data scientist, right? The data scientist is the data is the new oil. Everyone was saying that. And with data science, you can do this, you can do that. There are great job opportunities. People are getting 1 CR package, 20 lakhs, 30 lakhs, 50 lakhs as freshers, right? And truly, to be honest, that was happening with a lot of people I know. And looking backwards, I also enjoyed a lot of advantage because I was a part of a career that not a lot of people were ready to uh, serve that career, right? If very few set of data scientists exist, then automatically the supply demand chain will ensure that the value of data scientists increase. And that was the same thing that happened with a technology called blockchain, right? So blockchain had introduced a new programming language, all of these, the programming language was called Solidity. Then there were a lot of technologies that came up with blockchain. You definitely would have heard of Bitcoin, Ethereum, right? They're based on blockchain technology. Then so many startups got created that worked on blockchain as a concept. And, college freshers in the third year, fourth year were being paid. I actually know this as a fact. They were paid like 60, 70 lakhs per annum just because they had adopted to a very fast moving field, which was fairly new. So let me give you a logical understanding of why this happens in the industry. Okay. In the general flow of the industry, why does something like that frequently keep happening? Now, imagine an individual who completed his engineering in the age 2000, in the year 2000. Okay. In 2010, after 10 years, right, what was his current lifestyle, right? He would probably have a family. He was looking for a stable job. He might be heading a big company. He might be a VP, SVP, director, kind of a role with 10 years of experience. So whatever he has learned so far between 2000 to 2010, he's serving or offering that as a skill set. But now a certain new technology comes in the age of 2014. Okay. When he's, let's say, 14 years experienced, a disruptive technology came which kind of cancelled out a lot of the work that he has done in the last 14 years. If this guy who's 10 years, 14 years experience adapts to this new change, then he'll be much, much more valuable because he knows how things were done in the past, but he also knows how things are going to be going to get done in the future. And these guys would be super, super valuable. But what usually happens after a certain age, people do not want to work like a startup environment. They're not going to put 15 hours every day for their work. Obviously, there are exceptions. But a lot of people would want a stable life, want to spend time with their family, with their children, with their parents. They want to, go on vacations, things like that, which is not wrong, right? They've worked hard for 14 years. Now they want to take life at a decent pace and enjoy life. But then there comes the, fresher engineers, second year, third year, fourth year guys, or, freshers from different streams, from commerce, from law, different parts of domains and criterias. These guys, when they come in, they have the energy to learn something new, implement and move forward, right? They learn this disruptive technology and become very, very valuable compared to someone who had ignored this technology. Okay. And these people have actually taken, like, in their career, in their lifespan, they've taken like a 2x, 3x jump because they've actually adapted themselves to a new technology that's now going to rule the world, right? And that's the exact same thing that happened with blockchain, with data science, and which is right now happening with generative AI. Does that make sense, everyone? Logically, everyone understands why generative AI is going to help you a lot in your career.
Yes, sir.
Okay. The logic remains intact. If there's a disruptive technology and you catch the train quickly, you stand a chance to be a part of a very fast moving thing. For example, what if you would have been a part of Zomato when it was starting up, right? 5 years ago, let's say Flipkart, right? Or any of these new tech giants, Facebook, Apple of 20 years, 15 years, right? What if you would have been a part when they were creating value innovation with new technology, right? Today, you would have been in a completely different league. Other than choosing a technology that is 20 years old, if you choose a technology that's 6 months or 1 year old and you become an expert, right? The adaptation curve of any technology That's also something which will be very important for you to understand. Let me draw a chart and show you. So any new technology that comes up, right? Any new technology, the adoption happens something like this. Okay. There's a very famous book called Crossing the Chasm. Okay. If you're interested, you can definitely like go and read about that book. Let me just clear this. There's a very interesting book called Crossing the Chasm. And it actually takes you through this journey. Any company, whenever they are, building a new technology, there is a different way technology gets adopted. There's the innovators, the techies who quickly adapt to new technology, right? They're completely techies. Then there's early adopters within large organizations. These are the visionaries. These folks want to make sure that, let's say, in my company, I'll adopt AI super fast. Then there's early majority. Then there's conservatives who want to make sure that let everyone try it out. If we see success for everyone else, then we are going to enjoy the success ourselves or try it out later. And then there is laggards who never really adopt to the technology and ultimately become obsolete. Okay. So we want to actually be a part of this segment, right? Early adopters, the visionaries, right? So if you think about it in that way, you want to be a part of a technology that's fairly new, that has a lot of potential, and you want to adapt quickly. So you become an expert while other people get started on working on that technology. Okay, so that should be your motivation to jump on the train, which is leading towards generative AI expertise. Okay. Now it's transforming industries, enhancing creativity, improving efficiency. These are all the things that you might have heard outside also. But we are going to give you some very important facts. Okay. Generative AI has a very small percentage of users in the front line. That seems to be a big challenge in the industry. So what happens is the leaders of organizations, they have a lot of time to think about where to drive the company. So they are reading a lot of articles. They're going through their network and talking to people. And they have a huge understanding of the scope of generative AI. So they are learning, they are exploring, right? The managers have comparatively higher pressure than the leaders because they want to do the day-to-day stuff. They want to make sure that the company is running and functional every day. So they cannot spend a lot of time in the visionary goals. Obviously, they try to, but not as much as leaders. But the frontline employees, the associates, the senior associates, the backend developer, the front-end developer, the intern, these guys are not actually given the time, the energy, or the awareness to learn about generative AI. Which is why if we are a part of frontline employees, I'm assuming a lot of you would be a part of this. If you're a part of management and leadership, then definitely you are on the right place. But if you are a part of frontline employees, then this is the best place to be right now. Because here, the expansion of your knowledge will actually make you more suitable to become a manager faster. Right? Your corporate ladder will be accelerated because these people need frontline employees to know generative AI and start doing the work on generative AI. Right? That becomes a very good score point in your employability in the market. Right? You don't have to be like a PhD from Stanford and then learn generative AI. Okay. There's a lot of ways where you can excel in it without being the core developer of the algorithms. You should be a user of those algorithms. If you can build products on top of the core technology and sell those products or be a part of the company that's building those products, then also you are very valuable. Okay. Everyone clear? Yes, no?
Yes.
I'll answer the questions towards the end, okay? Not now. I want to complete the content and then we'll have Q&A.
Yes, sir.
Okay. So the more experience and familiarity you have with generative AI, the more likely a company is to experiment with it and try to find you and hire you. And then you deploy your product. You go through the early stage of understanding the flaws. You know where it works. You know where it fails. You know what you need to improve. And you also understand what can you offer. Think about it. Let's say you develop one simple product, and that product is ChatGPT like tool, but with the interface of a bank's website. If you go to a bank, on the bottom right, as a matter of fact, not even banks, if you go to any website and on the bottom right, you see a lot of those chat boxes opening up, right? Which are automated chat tools. Have you guys seen that? Yes, no? Yeah, those chat applications on the bottom right. Let's say you build that chat application for one company. Okay, you've got an experience in using generative AI and building that chat bot for one particular company. Can you not sell your expertise, or I would say replicate your expertise for 10 other banks? Is the bank the primary user or the website? Any website which needs a chat agent, a chat bot, will hire you to use generative AI and build it for them. You want to do it for Axis Bank, for HDFC, for ICICI, doesn't matter, right? The only thing is every bank wants to use generative AI, and you are one person they found who knows and who's done this in the past. So your expertise, your value, manifold improvement. Okay. Now you want to actually be a part of this 37%. Think about it. We do not fully understand GenAI and actively discourage its usage across our organization. This is not somewhere where you want to be, because they're not going to use GenAI. In the maturity scale, then there's the higher side, which is GenAI is already a source of business value. We are prepared our organization and build capabilities. This is where the job is mostly done, right? Then we view GenAI as a source of value going forward, setting up guardrails to support teams. This is still fine, but a major bracket is this one. People who are experimenting with GenAI. So you get the experience, you build things from scratch, you are the part of the core team that's developing something future worthy. Okay, so that should be your target. Coming to the evolution idea, right? Where did all of this start from? So you might be shocked and surprised to know that AI or machine learning or deep learning are not new technologies, right? They were like 1960s, 1970s, 80s. There's actually a term called the AI winter, which lasted approximately 20 to 25 years. Because the algorithms that people suggested, which were mathematical, those algorithms are pretty old. For example, an algorithm like linear regression, random forest, support vectors, dimensionality reduction techniques, principal component analysis. So many of these technologies were actually born 40 to 50 years ago. The first multi-layer perceptron was actually there in the 1960s, 1950s, right? Why did these technologies gain so much traction in the recent past? Can anyone tell me? My question to all of you is, if these algorithms and these technologies theoretically were ready 50 years ago, why did they start gaining so much traction just 10 or 12 years ago? Why was that? It was because computational capabilities have developed recently, right? Remember 10, 15 years ago when you might be in school, what was the internet speed that we used to experience with those BSNL routers? It was maximum 100 kbps, 500 kbps. When we used to get 1 Mbps, I used to go crazy because now I can download so many games, right? Like the best of the speeds was 1 megabytes per second. So data transfer. Now data transfer was so slow that automatically means data collection was slow, the size of the data was low, etc., etc. Today we get speeds worth of 100 Mbps, 200 Mbps, 500 Mbps, right? That completely changed the dynamics, because now There can be more dynamic websites which can collect data. Data can be in terms of YouTube videos, which you might have seen 4K YouTube videos. Imagine the kind of bandwidth required for a computer, the internet network, to actually run a 4K video on your computer or on your phone, right? It's drastically different. So the computational efficiency that has been developed, the cheap availability of memory like RAM, as well as hard drives, as well as compute instances, cloud computing, AWS, Azure, Google Cloud Platform, all of these have made a substantial effort in building these technologies. You must have definitely heard that to train these algorithms that work behind ChatGPT, millions of dollars are being spent. Where are those millions of dollars being spent? They're spent on computation, on GPUs, on cloud computers that are doing all of these tasks, these heavy computation processing, etc. Right? So theory existed, but practically we could only build those systems with the advent of technology. So practically, if you see, AI was something which was way ahead of its time in 1960s or 70s, right? It's only when computation developed, when there were other things supporting this environment, then when it started happening, okay? So that was the rise of machine learning era. From the 2010s, we moved from machine learning to deep learning, which is more like an advanced version of machine learning where you don't need to make assumptions. For example, if you want to build a linear regression model, okay, I'll give you an example here. If you want to build a linear regression algorithm, the primary assumption of that algorithm is that your data should be linear. Does everyone understand that? Yes or no? The primary assumption behind using a linear regression model is that your data should be linear, right? If your data is linear, only then you will be able to create a linear regression algorithm, which let's say is this line. Okay. But if your data is non-linear, then you need to use a different model. If your data is a combination of linear and non-linear, then you again need to use a different model. So what happened with machine learning is a lot of assumptions had to be made before picking the appropriate model that could solve your problem. Priyanka, for now, assume that linear regression is a machine learning algorithm that gives you a predictive algorithm, right? For example, just see if these are the data points available to you, the red data points. These are examples available to you. And you are able to create a blue colored line, which is the linear regression model. Given any new point, you will be able to predict what is the value of output. So for example, if a new X is given, you can predict what the Y is. Okay, don't worry about the linear regression algorithm. Just understand that traditional machine learning used to be very, I would say, involved a lot of assumptions. Okay. Then came deep learning, which did not require that many assumptions. If you have a very complex function which has multiple simple relationships, complex relationships, linear, non-linear patterns, or any kind of pattern, deep learning algorithms, models could actually understand them. So it was a very generic model that could give you a predictive algorithm. So the image you see here is of a deep learning model, right? That's when for vision-based solutions, like if you want to predict based on an image, right? You are given photos of animals and you want an algorithm, you want a machine to predict if that photo is of a cat or a dog or a horse or etc. Right? So that was a vision-based application. There also a version of the deep neural network architecture, the convnets were used, right? Then for time series based problems, where let's say you want to predict the stock prices, then you would use something like the recurrent neural networks, right? And this is the era where all the big companies, Google, Facebook, Microsoft, they were all focusing on creating neural network architectures that can solve the problems that no one today has solved. Okay. For example, if I take you to AlphaGo competition. What was the AlphaGo competition? Google DeepMind, one of the verticals of Google, which is focused on building deep neural network based solutions, right? In 2014, they challenged the world's best at that time player, 𝐿LM, right? Is a professional, former South Korean professional Go player of 9th Dan rank. That means he's one of the guys who's like an expert in that game. And then Google DeepMind used a machine to beat this guy. Okay. The algorithm was called AlphaGo, a computer Go program developed by DeepMind. AlphaGo won all but the fourth game. All games were won by resignation. That means the expert quit the game because he knew he's lost. Okay. The winner of the match was slated to win $1 million, and Google AlphaGo, Google DeepMind program actually won that competition. Okay. So that's what was happening back then, right? They were trying to create algorithms, trying to create programs that could beat humans who are experts. So they're kind of challenging the human brain using artificial brain, right? So let's look at the quick timeline. So in 1962, artificial neural networks were kind of imagined. Then there was an AI winter, like I mentioned, till 2006, right? AWS, Amazon Web Services, were launched. NVIDIA releases CUDA, which is the programming language for GPUs, right? GPUs are the hardware that is used to train these big models, right? So you can imagine a GPU's cost, right? GPU A100. This is like the starting level GPU that you would need to train these big algorithms. What's the price of that? 11,50,000, right? So it's worth more than a car, this GPU. And why is this GPU needed? These GPUs are needed to build or train these big scale algorithms, right? So in 2006, that happened. Then 2009, see, technology is catching up, right? Technology is catching up. Then algorithms are catching up. And then this is where first time ever a core architecture of the transformer models. So it's called a transformer architecture, and ChatGPT, all of these generative AI tools are largely derived from this transformer architecture. This is the paper again, which came from Google DeepMind in 2017. Then in 2018, GPT-1 came out along with BERT. BERT is Google's version of a generative AI tool. Then GPT-2 came out. Then GPT-3 came out in 2020. Then GPT 3.5 came out in 2022. This is where you would have experienced ChatGPT the first time. And today you can see Microsoft announces a lot of things. Google is working with a lot of GPT-based models. Meta, which is, Facebook, released their tools. A lot of these things are coming up now. Why? Because computation has caught up. Algorithms are now more meaningful to handle today's challenges, today's problems. And that's where we are going forward, right? Now, new algorithms are coming up. New strategies for efficient computation are coming up. New models are coming up. And they are solving a lot of interesting challenges. Okay. To give you a glimpse of one of these types of algorithms. So one of the generative AI algorithms is called generative adversarial network. Okay. What is a generative adversarial network? It uses two neural networks. Okay. One of the neural networks is called generator. The other is called the discriminator. So think about it. The task of the generator is to generate random images. Simply, the task of a generator is to generate random images. And the task of the discriminator is to discriminate between a real image and a fake image. Does that make sense, everyone? There are two algorithms, two models, one of which is tasked with generating random images. And the other, the discriminator, is tasked with discriminating between which one is a random image, which one is an actual image. So see this, in your training data, when you are training these models, you are sending real images also, and you are sending fake images also. The discriminator's job is to tell which one is real, which one is fake, and the generator's job is to generate fake images. Now, I am training both the generator and the discriminator. When I say I'm training, that means I'm improving their potential, their performance on doing the task that they're supposed to do. So the generator's task is to generate more real-like images. And the discriminator's task is to look at two images and figure out which one's fake, which one is original. So the idea is, over time, through the process of training, the generator will become an expert in generating fake images which look like real. And the discriminator's task would be to distinguish between fake and real images and find out which one is real. Let me give you a very interesting example. This person does not exist. There is a website called This Person Does Not Exist. What does it do? It does a random face generation. Okay. Let's say male, age 26 to 35, ethnicity Asian. Let's see an image. We see an image. 3. Generate random human face in one click and download it. AI generated fake person photos. What is being used here? The generator. It is generating a fake image. We close the ad. What happened? Okay. See this example. This person does not exist. Do you think this is a fake image? Does anyone think this looks like a fake image? Does it not look like a real child's image? But it is actually fake. Can you see at the bottom what is written? Style GAN 2. What does GAN stand for? Generative Adversarial Network, GAN, right? So this is one of those models which generates images. You refresh this page, you get a new photo. And this again is a fake photo. You refresh this page again, you again get a fake photo. And it generates such realistic photos that you would not be able to imagine that this is unreal, this is fake, right? So the generative adversarial network, it generates images which look like real but are actually fake. Is that clear, all of you? Yes, no?
Yes.
See this, what does it say here? The generator produces new data while the discriminator assesses its authenticity, refining until the generated content matches the original data set. This autonomous learning process resembles a supervisor refining its skills without constant human oversight. So you can actually leave the generator and discriminator. They will keep doing this for so many iterations, let's say 50 million images or 1 billion images. And eventually the generator will be able to generate real images, fake images that look like real. And the discriminator will have the strength to distinguish between a real and a fake image, right? Another example of this is the generative pre-trained network, generative pre-trained transformer. Sorry, it's misspelled. Okay. So this is the generative pre-trained transformer model, okay, which you might have guessed is GPT. Okay, so ChatGPT, the chat version of the algorithm is called ChatGPT, but GPT is the generative pre-trained transformer. Okay. Now, let me first give you the intuition or the inspiration behind building something like this. In earlier stages, what was happening was everyone wanted to solve a problem called neural machine translation. Neural machine translation. What is neural machine translation? You get input in a certain language, language 1, and you want to translate it to another language, language 2. This is the process of machine translation. If you want to use a neural network to do this, then it will be called neural machine translation. Now think about the step-by-step approach you would take today to solve a problem. Will you do a word-by-word translation? Think about anything in your language, in your mother tongue, and think about translating that to English word by word. Word by word. So let's say, मैं घूमने जा रहा हूँ. Suppose I'm just taking an example in my mother tongue. Okay. Me traveling, go, am, yes, something random. Okay. Just trying to prove an example that you cannot do word by word translation when it comes to language translation. Does everyone understand that? Yes or no?
Yes, sir.
Right? Whenever we are translating, it's stupid if we do word by word translation. So that begs the question, how does our mind do translation? Let's say you have a friend, let's say you have an American friend and he comes to your country, your city, and you take him out to, visit the places where you visited as a child. Okay. And he asks you questions in English, and you want to translate it to, let's say, a food vendor, a food cart vendor. He's asking something, let's say he says, is this vegan? Right? You both went to a puchka stall and your friend asked, is this vegan? So what would you do? You'll first try to understand what he's saying and then translate it in the language of the vendor. Yes or no?
Yes.
Right? So kind of the intuition is first encode what has been said for meaning and context. Okay. Then decode the meaning into the new language. So between the translation, there are two parts: the encoding of something and then decoding of something. Does that make sense, guys? Yes or no? Encoding as well as decoding. You don't want to do word by word translation. See this in the bottom, there is the French language. Je suis étudiant, right? What is it saying? It's actually saying that I am a student, right? But it is only 3 words. If I do a word by word translation, I can only do 3 words. But to say that in English that I am a student, I have to say correctly, I am a student. I can't say I a student. I can't say I am student. I am a student. That's the correct English pronunciation, context, semantics, right? So first I encode this information using the encoder part. This output of the encoder goes into the decoder, and then the decoder generates words one by one, right? That is the idea behind a transformer architecture, which is feeding the generative AI world today. What does this transformer architecture do? It has two parts. It has the encoder and the decoder. The encoder encodes the sentence and the decoder decodes the meaning, decodes to a new sentence using the meaning from the encoder. Okay. That's the idea behind these new age models. So one was generative adversarial network. The other is generative pre-trained transformer. And then there are a lot of variations of these. Okay. So this generative pre-trained transformer, okay, how does it work? How does this get trained on all of these, data, and how can it predict? So GPT is short for pre-trained transformer, generative pre-trained transformer. Generative means it is generating things. The decoder is generating items one by one. Pre-trained means it has been trained on a lot of data, a large corpus of data. And transformer means it uses the transformer architecture. Okay. And it is the Premier League language model developed by OpenAI, which you call the GPT-1, GPT-2, GPT-3, GPT 3.5. Then GPT-4 is valid today, and there are talks of GPT-5 coming up as well, right? And these models have the advanced capabilities of understanding natural language in a very, very deep, semantic, meaningful way. If you ask a question to ChatGPT, you will never feel like it is superficial. It actually understands the way you've written things, and it responds in a way that you will understand things, right? You will not see poor English construction. You will not see, words being jumbled up. You will always see a very structured response, right? So these models are actually trained on the entire internet. One way to think of a GPT-based model is that it is a compression of the internet. The internet has a lot of data, the Wikipedia articles, the Reddit, Facebook, messages, images, etc., etc. Let's say if I take the entire data that is available on the internet and I can compress it down, that compression is my GPT model. It knows the data, the sentence framing, the structure of the entire world, and now it understands language in a very, very professional way. So we take the entire data source, right? All the data that is available, and then we train this foundation model. The foundation model is basically a model that can predict the next possible word. If I'm given a sentence, what can it do? It can predict the next possible word. And once I have the foundation model, which understands language, meaning, context, things like that, I can then do something called as fine-tuning or adaptation of this foundation model on downstream tasks. So the difference between GPT and ChatGPT is this. GPT is the foundation model. It has been trained on the data from the entire internet, and it can only predict next word. But we wanted to fine-tune it for a downstream task, which is a chat application that feels like two people are talking to each other. Chat version is this downstream task, this expertise, this fine-tuning of a base model, foundation model for a particular application, chatbot. Does that make sense, all of you? Yes, no? Guys online? Yes, no? Everyone? Okay, great.
Yeah.
Now, because of this technology being so particularly advantageous, there's a lot of quality and efficiency impact that it has on the world. Sales, marketing, supply chain, R&D, pricing, strategy, risk compliance, finance, manufacturing, all of these different sectors, domains have been benefited directly with generative AI. There's a vast variety of applications. Like if you go to all these big websites which tell you where are the VCs, the venture capitalists, putting their money for the last 1 or 2 years, all of them are putting their money in generative AI based startups. And the funding is like $100 million, $200 million funding, right? And these people are exploring a technology which, if successful, can have such a huge advantage to the human race, right? That a lot of people are betting on the future of generative AI, right? Which is why it has tried to transform so many domains. It already has, and we are still looking for, the core businesses, the manufacturing businesses, the supply chain industry, so many different industries that exist today. There is like a transformation going on for all of them with usage of generative AI. Okay. Corporate adoption has actually now started increasing by a huge rate. So earlier, only tech companies were doing generative AI. Now, non-tech companies and organizations, domains are also leveling up. They are trying to include wherever they can the applications of generative AI, starting from accounting, teaching, consulting, wherever they can add generative AI and use generative AI, they are using it. Right. And, whenever we are learning something today, we are not learning it for, next 2 years or 3 years. We are learning it for the next 10 to 20 years. By the time you are in the phase of your retirement, where you don't want to, work 15, 20 hours a day, where you don't want to work on the weekends, where you want to have a very comfortable, successful life, you want to learn a technology today that's going to last for the next 20 years, right? So that should be your motivation to pick up generative AI as a technology that you must learn. Okay. So to quickly conclude, investing today in your Gen AI skill set or learning these Gen AI tools or upskilling yourself will give you a huge advantage across any organization that you're working with. You could work for a startup or an MNC or a local company. Everywhere, the idea of inducing generative AI in the day-to-day activities of the company, which will save time, money, and improve quality, you would be at the center of someone transforming your company's current work environment. Is that clear, all of you? Yes, no?
Yes, sir.
Even data scientists, machine learning engineers, 2 years, 3 years down before, these used to be the most sought after jobs. Like, I'm a data scientist, I earn this much, I'm solving this big problem for this big company. Right? Data science was a new field, and a lot of people got in early and are making handsome rewards, enjoying handsome rewards today. Right? Similarly, generative AI is one of those technologies where you could be there in the next 2-3 years. But trust me, a lot of data scientists and machine learning engineers are also looking forward to upskill themselves in generative AI. Right? So people who are already present, they are fearful of not adopting to this technology. Right? And very few times you get these opportunities where you can completely learn something new, because not a lot of people know it. And because you've learned it early on, you will get a lot of opportunities to scale your knowledge. Right? If you get in one company that is doing some kind of Gen AI product development or experiment, the things that you will learn at the job over the next 1 or 2 years will make you so much more valuable for your next job. Or, as a matter of fact, if you want to open your own company which uses generative AI. So that experience becomes very valuable, and that you will only be able to get if you understand and learn about it, and then apply for companies that are looking for these Gen AI professionals. Okay, so yes, that was it. And I think we've ended at a perfect time. It's 4:55. The next 5 minutes are for Q&A, guys. I welcome any or all questions. You can turn on your microphone and ask any question. If the question's long, no problem. How is fine-tuning done? So fine-tuning is done by using two strategies. The first strategy is using actual humans. Okay. So the bot or the algorithm generates some kind of examples, and the human validates. Right? The human says this is a better answer, this is not so good answer, or they can rank 5 answers. Let's say the bot generates 5 different answers. The human will rank those 5 answers, and then the bot will be trained to generate the answer which has got the best rank. Right? If you do that for 1,000, 2,000, 5,000, not that small, 100,000, 200,000, 500,000 questions, then the bot slowly and steadily develops a very professional communication, expert communication. Which GI is best for data analysis? Data analysis is different, Swastik, from generative AI. Particular course for learning Gen AI, you can get in touch with the IB team. They will guide you better on the educational consultancy. They have a lot of programs, and they will try to recommend the one which is more suitable for your current career. Right? Where you are in your career, how much experience do you have, which domain you're coming from. They will basically do an analysis of that and then try to fit a particular course for you, which would be best and high ROI for you. What are the most relevant tools to learn Gen AI? You should definitely learn Python as a programming language. Then you should be understanding the primary concepts of deep learning architectures, models. You should know a deep learning development framework like PyTorch or TensorFlow. And then you should definitely solve a lot of problems, do a lot of small projects to get a understanding of the diversity of solutions. That should be a good start for learning GenAI. Where is neural network composed with GenAI? So in GenAI, the architecture that I showed you, the transformer architecture, the encoder and the decoder are neural networks. Okay, they host different kinds of neural nets. GenAI in data science. GenAI is a part of data science today, Ashish. So if you know GenAI, it will definitely help you in data science. Whenever you're trying to look for topics which use some kind of enterprise data and feed that to the transformer or the GPT-based models and solve a certain problem. For example, you might have learned of SQL, right? SQL as a programming language. So every company needs to hire these big data engineers, data analysts, because the company leaders will say, I want to know what is the performance of this with respect to this. Then a data engineer actually goes and writes the SQL query to extract that data and shows the report to the leader, right? Instead of the data engineer, a generative AI tool can also do that, right? So given the database schema and the question of the user, a generative AI bots can generate the SQL query that will solve the problem. So that's one example. So anything that acts as a bridge between a human and a machine, wherever generative AI can be applied there, that should be your preference. I have 5 years of experience. My experience has been awesome. I've really enjoyed. Shashank, if you are a non-technical person or if you like are starting from scratch, then certificate really helps to get you into the shortlisted resumes section. Without a certificate, just claiming that you know a technology usually does not help, because there are a lot of other competitors who have a certificate, who have a degree, and they have projects as well. So, the primary importance for you is to first get in. Once you get in, then the skills matter, right? But you have to get in first. No, Indrani, GenAI and predictive analysis is not the same. How much threat GenAI brings to a lot? I mean, not in terms of threat, but in terms of efficiency. And, if you're doing a job that any computer or machine can do, then your job is at a threat, right? Anything which occupies the human mind, a creative job where you need to apply brains, where you need to, think a lot, deep, complex problems, those jobs are safe. But, write an essay about this, that's something that, AI can do much better, faster, and professionally than you. So yes, that would be a threat. For example, data entry will be a threat, right? Because now machines can do it. How can we get the participation in what, Ashish? Chaitanya, to get prepare for GenAI hackathons, you need to learn GenAI. You need to do a lot of projects. That's all. Just pick up GenAI problems and try to solve them. Priyanka, you can definitely get in touch with the Ivy team. They have educational counselors who will guide you as per your current situation. Okay. If I give you a solution that's not very useful, I don't want to misguide you. Okay. The educational counselors will definitely be able to help you better. They have experience with handling a lot of students, and they know which student can succeed in which way. So definitely connect with them. No, not necessarily, Shubhankar. Chat is what is usually available to the general public, because that's what they can use in general. Okay. But there are a lot of other applications of GenAI which generally are not open to the public because the public doesn't need them. For example, a manufacturing focused GenAI tool, right? Who's going to use it? A general public won't, right? You know about ChatGPT because it's a general public tool. But there are a lot of specific niche domains where generative AI is being used, and you or I wouldn't get to know about them. GenAI was based, but the earlier chatbots were not purely GenAI based, but today all the chatbots are GenAI based, at least in the major organizations. everywhere it's GenAI. In general, how the plan of taking up new skills should be. Priyanka, again, I don't want to give you an answer which is not tailor fit for your career. Okay. Prompt engineering uses Chaitanya. It's like once you understand GenAI, then you want to learn something called prompt engineering, because prompt engineering is a way to communicate with computers. Just think of it that way, right? You go to a new city and you want to learn their language, right? How do you learn their language? You understand the framing of sentences. You understand what strikes a chord with the people of that country. To communicate with GenAI tools, you have to write prompts. Prompts are a way to communicate with them. And how do you engineer those prompts? By making sure that the algorithm in the back is aligned with your way of asking questions. Okay, that alignment is what prompt engineering is called. Commerce background students also a lot. I personally know like CA friends of mine who are using generative AI. They are actually analyzing a lot of financial documents. They've deployed a generative AI model in-house, so they are not using OpenAI or ChatGPT kind of a thing. They are deploying it on their own system and using it to read and analyze financial documents. So definitely, there's a lot of scope. Claude is also another alternative of OpenAI, Anthropic, Mixtral. These are all different service providers. You can choose the one that fits you the best in terms of cost, speed, scale, etc. Jiria, you would face certain technical challenges. You should have you should know elementary programming. You should understand fundamental mathematics behind these algorithms. But yes, definitely any program that tells you that they're going to teach you generative AI, they will definitely have a comprehensive structure curriculum where they will take you through step by step, assuming that you are not coming from a technical background. I mean, at least Ivy does that. I'm sure of that. Okay, guys, we'll have to end the webinar here. I really enjoyed taking you guys through the journey, and I would have loved if someone would have taken me through this journey 2 years back when I started learning about generative AI. And I hope all of you enjoyed the session and you got the inspiration of at least learning this technology, and definitely try to explore more on it, read, go through YouTube videos, try to understand what's happening, and be actually realistic with your expectations, right? So you might not get like a 50 lakhs or a 1 CR job, but in any new field, even if you get an internship, it's very valuable. So prioritize learning versus money right now, because if you learn and if you catch the train today, 2 years down the line, you will not imagine the kind of money you will be getting, just because you have excelled in a skill. Okay. So thank you so much for joining in today. I will see you in some other webinar. Have a great day. Thank you. Bye.